Friends, welcome in our own teacher channel. Class 10th Science 1 Workshop of Lesson number 10 Space Missions. Before starting the workshop, subscribe my channel and to get notification, touch the bell icon. Question 1. Fill in the blanks and explain the statements with reasoning. If the height of the orbit of a satellite from the Earth's surface is increased, the tangential velocity of the satellite will decrease. Explanation. Tangential velocity of the satellite is given by the formula in root gm upon r plus h. This implies velocity of the satellite directly proportional 1 upon in root r plus h. Hence, when height of the orbit of the satellite is increased, its tangential velocity decreases. The initial velocity of the Mangalyaan must be greater than the escape velocity of the Earth. Explanation. Mangalyaan is a spacecraft made by ISRO under its mission to Mars. Mangalyaan must escape Earth's gravitational force to reach the Mars. To achieve this, the initial velocity of Mangalyaan must be greater than the escape velocity of the Earth. Question 2. State with reasons whether the following sentences are true or false. If a spacecraft has to be sent away from the influence of Earth's gravitational field, its velocity must be less than escape velocity. False. If a spacecraft has to be sent away from the influence of Earth's gravitational field, its velocity must be equal to or greater than the escape velocity. The escape velocity on the moon is less than that on the Earth. True. The formula of escape velocity is in root 2gm upon r. As for moon, both m and r are smaller than that for the Earth. The combined result of change in m and r makes the escape velocity of the moon lesser than that of Earth. A satellite needs to a specific velocity to revolve in a specific orbit. True. The satellites are moving in different orbits are at different heights from the surface of the Earth. The tangential velocity of the satellites is given by under root gm upon r plus h. As the velocity depends on height of orbit, every satellite needs a specific velocity to revolve in a specific orbit. If the height of the orbit of a satellite increases, its velocity must also increases. False. Tangential velocity of the satellite is given by the formula under root gm upon r plus h. This implies velocity of the satellite is proportional direct to 1 upon in root r plus h. Hence, when height of the orbit of the satellite is increased, its tangential velocity decreases. Question 3. Answer the following questions. What is meant by an artificial satellite? How are the satellites classified based on their functions? If a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called an artificial satellite. Depending on their function, satellites are classified into following categories. Weather satellite. These satellites are used to study and forecast weather conditions on the Earth. Communication satellite. These satellites use specific waves to establish communication between different locations in the world. Broadcast satellite. These satellites are used to telecast different television programs all over the world. Navigational satellite. These satellites help in locating any place on the Earth. Military satellite. These satellites collect information for security aspects of nation. What is meant by the orbit of a satellite? On what basis and how are the orbits of artificial satellites classified? The path followed by a satellite while revolving around the planet is known as the orbit of the planet. Depending on the height of the satellite's orbit above the Earth's surface, the satellite orbits are classified as below. 1. High Earth orbits. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 km, the orbit is called high Earth orbit. A satellite revolving in such orbits takes around 24 hours to complete one revolution. These satellites are called geosynchronous satellites. 2. Medium Earth orbits. If the height of the satellite orbit above the Earth's surface is between 2000 km and 35,780 km, the orbits are called medium Earth orbits. In these orbits, the satellites complete one revolution in 2 to 24 hours. These orbits are also called as polar orbits. Number 3. Low Earth orbits. If the height of the satellite orbit above the Earth's surface is between 180 km and 2000 km, the orbits are called low Earth orbits. They complete one revolution in around 90 minutes. International Space Station revolve in low Earth orbit? Why are geostationary satellites not useful for studies of polar regions? Satellites revolving around the Earth with the time period same as that of rotation of Earth are called geostationary satellites. These satellites revolve in orbits parallel to the equator of the Earth at highest of around 35,780 km from the surface of the Earth. As the orbits of such satellites are always above the equator, these satellites are not useful for studies of polar region. What is meant by satellite launch vehicle? Explain a satellite launch vehicle developed by ISRO with the help of a schematic diagram. The vehicles with the help of which the satellites are placed in their specific orbits are called satellite launch vehicle. This PSLV is a 4-stage satellite launch vehicle. Each of these stages contain fuel which is burned, and each stage is detached from the vehicle after reaching specific height. There is a place at the top of the 4th stage to keep the polar satellite to be launched. First stage, along with 6 rocket booster engines, provides the initial thrust to the launcher. This stage contains solid fuel. The second and fourth stages have liquid fuel in them. The third stage works on the solid fuel. Second and third stages increase the velocity of the PSLV and help it attain the desirable height. The fourth and the last stage sets the satellite into its desired orbit. Why is it beneficial to use satellite launch vehicle made of more than one stage? Fuel in the launch vehicle forms the major part of the total weight of the launch vehicle. Thus, the vehicle has to carry large amount of weight in the form of fuel with it. For the launch vehicles with more than one stage, the fuel in the first stage is used to give the initial thrust to the vehicle. After this fuel is exhausted, the empty fuel tank along with the engine is detached from the main body of the vehicle. This reduces weight of the vehicle step by step. Hence, it is beneficial to use satellite launch vehicles made of more than one stage. Question 4. Complete the following table. IRNSS, INSAT and GSAT. IRS, fixed location of any place, weather study and predict, study of forests, deserts, oceans, etc. Navigational, weather, Earth observation. Question 5. Solve the following problems. If a mass of planet is 8 times the mass of the Earth and its radius is twice the radius of the Earth, what will be the escape velocity for that planet? In this problem, given mass of planet 4m, radius of planet 2r, we have to find here escape velocity of planet. So our formula is in root 2gm upon r. So we will do calculation in root 2gm upon r means 2g in bracket 4m upon 2r. We will cut here 2. Now remaining part we will take in root 4 into gm upon r is equal to 2 escape velocity. We know escape of velocity is equal to 11.2 km per second. So 2 into 11.2 is equal to 22.4 km per second. The escape velocity for the planet will be 22.4 km per second. How much time a satellite in an orbit at height 35,780 km above Earth's surface would take if the mass of the Earth would have been 4 times its original mass? In this problem, given new mass of Earth 4m, that means 4 into 6 into 10 raised to power 24 kilogram. Height of satellite 35,780 kilometer. We have to find out here time period, that means t. So we will use here formula number 1. Velocity is equal to in root gm upon in bracket r plus h, and our second formula is t is equal to 2 pi in bracket r plus h upon velocity. Now we will do calculation substituting formula 1 in formula 2. So t is equal to 2 pi in root in bracket r plus h cube upon gm. 2 pi in root 6.4 plus 35.78 in bracket into 10 raised to power 6 bracket close cube upon 6.67 into 10 raised to power minus 11 into 4 into 6 into 10 raised to power 24. We know r is equal to 6.4 into 10 raised to power 6 meter. After this calculation, we get answer 43,020 second. We will convert it into r. We know in 1 hour there are 3600 seconds. So we will divide here. After dividing, we get answer 11.95 h, approximately 12 hours. So this satellite would take approximately 12 hours to complete one revolution around the Earth. If the height of a satellite completing one revolution around the Earth in t seconds in h1 meter, then what would be the height of a satellite taking 2 under root 2 t seconds for one revolution? Critical velocity is equal to under root gm upon r plus h. Also, velocity is equal to distance upon time. That means time is equal to distance upon v. So 2 pi in bracket r plus h upon velocity for first satellite. T is equal to 2 pi in bracket r plus h1 upon velocity. 2 pi in root r plus h1 bracket cube upon gm. For second satellite, T2 is equal to, we know, 2 in root 2. So we will keep here T is equal to 2 pi in root r plus h2 bracket cube upon gm. Now dividing equation 2 by equation 1. We know T2 is 2 in root 2. So 2 in root 2 is equal to in root r plus h2 bracket cube upon r plus h1 bracket cube. Square both sides. 8 is equal to r plus h2 bracket cube upon r plus h1 bracket cube. So 2 r plus h1 in bracket is equal to r plus h2. So 2r plus 2h1 is equal to r plus h2. Therefore h2 is equal to r plus 2h1. The second satellite would attain the height of r plus 2h1 meter. So friends, thanks for watching this video.